Good day, everyone. Welcome to the School of IT at Monash University, Malaysia. My name is Vishnu Mon, and I'm the course coordinator for the Bachelor of Computer Science in Data Science program. What I'm going to do today is to just give you an overview of the Bachelor of Computer Science in Data Science program. I'll discuss to you about the definition of data science, how does it compare to other programs, what the opportunities in data science, the course structure, the course map, and then we'll discuss some of the faculty assessment hurdles. I will give you an overview of some of the projects that our students have undertaken in the data science field, and I will conclude with providing some additional links that can help you during your journey at the School of IT and at Monash University. So now a bit wordy slides here, okay, but nevertheless the words here are just meant to give you some information. So the Bachelor of Computer Science in Data Science actually started at Monash University, Australia back in 2016 or 2017. But here at Monash University, Malaysia, we received the provisional accreditation by the Ministry of Education Malaysia to start the program in late of October 2019, which is just last year. So the first batch of students, we were due to receive them in semester 1, we actually received them already, and now we welcome you, the second batch of our data science students, into Monash University, Malaysia. So data science addresses the aspects on how to capture, manage and use huge volumes of data generated by businesses, organizations and science in the information age. Alright, so generally speaking, the Bachelor of Computer Science in Data Science program is still a computer science program, just that it includes a formalized training towards data science. So that's why in your testament, in your certificate, it will show the Bachelor of Computer Science in Data Science. Now, just to clarify a bit more, the reason why, to run a new program in Monash, to run any program at an institution in Malaysia, we will need to acquire the accreditation by the Malaysian Education Board, in this case the Ministry of Education in Malaysia. Hence, that's why we have to undergo the accreditation process, which can take some time, and hence we got the accreditation to launch the program last year. So the possible careers for graduates includes business intelligence analysis, chief data officer, data analysis, architect, mining, data scientist itself, quantitative analysis and quantitative researcher. So now the key point that not only a lot of students but also the public in general have is, how does computer science differ from data science and software engineering? Now, if you look over here, computer science covers the core concepts and technologies involved into how to make a computer do something. So when we talk about computer science, we're looking at the algorithms, we're looking at the theory of computation, the artificial intelligence side of it, computer architecture, robotics, image processing, and so forth. Alright, now computer science in data science focuses on how we can manage, capture, and use huge volumes of data generated by various organizations to then analyze the data, okay, and then generate useful or impactful analysis from the data, which can be visualized to the stakeholders. So if you compare computer science and data science, computer science, they are actually very much similar. It's just that the data science includes additional formal training on how you do data modeling, big data management, data analytics, data visualization. So that is the main core element of computer science and data science. Alright. Software engineering, on the other hand, focuses on systematic discipline and quantifiable approach to build high quality software systems. So this is software engineering. Software engineering is more towards applying engineering principles of physics, mathematics, and also engineering design to actually design and develop software systems, large-scale software systems. Alright, so that is the core element of software engineering. Alright, so another slide to show the differences. Computer science cover the core concepts and technologies involved on how to make a computer do something. Computer science and data science cover the core concepts on how to capture, manage and use big data generated by various organizations, and then from there apply analytics to derive impactful outcomes which can be visualized to the stakeholders. Software engineering focuses on the systematic, disciplined, and quantifiable approach to build high-quality software systems. So, this information was actually retrieved from online. All right. So, how do these fields differ? So, as I mentioned, computer science encompasses all aspects of computational systems from theory to application. Data science is an interdisciplinary field that utilizes scientific methods, processes, algorithms to extract insights from massive quantities of data. So this is generally the core. How did they differentiate themselves in the term of the fields? Occupation-wise, data science can go into data scientists, data architecture, data mining, software developer, statistician, and intelligent analysis. Now, that's not saying that a data science graduate cannot actually pursue computer science fields. No, it is perfectly fine. It's just that the data science training that you undergo provides you with the foundation and applied knowledge which will allow you to pursue a career as a data scientist. Alright, so the new emerging occupations, we go into AI, machine learning. These are some new emerging occupations for students with data science backgrounds. Okay, so the bottom line, okay, so data science is relatively a new field. Okay, the offsprings of statistics and computer science. So generally, data science includes more statistics, which you will learn more from data analytics and also modeling for data science. Data scientists may design algorithms, refine data sets, okay, and parse vast swaths of data through mathematical models to generate actionable insights. Alright, so that's the whole idea of data science. So if you look at the last sentence here, if computer science is building a new infrastructure, data science is extracting and filtering of the new and valuable global commodity that enables. So that is the idea of data science in computer science. So in terms of career opportunities, as I mentioned, if data scientists, data engineering, data analytics, so this is something that for you all to actually read at your own convenience. The slides, okay, so I think the copy of the slides will be made available to you all also. Salary wise, this was based on the 2020 Malaysian salary benchmark by Michael Page. So if you can see that for minimum means that entry level requirements, we're looking at anywhere between 60,000 to 78,000 data analysis. But if you look at data engineer, data warehouse, business intelligence, you can see the salary range is much significantly higher, and this is just a base salary range. In actuality, data scientists can earn significantly more. They can actually have a very successful, rewarding career based on their competency and also their experience. So, based on this is the overview. All right. Now let's look at the cost structure. So the cost structure for Bachelor of Computer Science and Data Science is similar to the Bachelor of Computer Science. So you've got 144 points. Okay, so one unit has a number of points, so you have to complete 144 points. 96 points which must be taken from a computer science study. The remaining 48 points are used to provide additional depth and breadth through elective study. Alright, so before I go to the electives, let me just go through with the foundation first. So your course structure is broken down into several parts. Part A, Foundation of Computer Science, where you will start off with discrete and continuous mathematics, algorithm and programming fundamentals in Python, introduction to computer science. In this case, you'll be learning to introduction to data science, alright, introduction to computer systems, networks and security, and theory of computation. In part B, we will go into IT professional practice, alright. In part C, then you will you will actually learn introduction to computer science, my bad. You will actually learn introduction to computer science, but then in part C, when you go into the specialized discipline knowledge, you will then have an additional unit where you will have an introduction to data science. Okay, and then from there you have modeling for data analysis, databases, data analytics, data visualization, business intelligence, data warehousing, big data management and processing, deep learning, and our newly added unit, malicious artificial intelligence, malicious AI, and dark side security. Okay, and then in part E, in your applied practice, you will have a data science project and an industrial work experience or industrial based learning. I'll talk about this later on a bit. So Monash actually encourages students to do free electives. So electives allows you to take additional units within the school or from other schools or faculties in Monash University to actually enhance your knowledge. So in this context, you can actually enroll in additional statistics units or economics units from the School of Business to actually help you develop some understanding on the business side, or you can actually go and enroll in certain life sciences units from the School of Science to give you a general science understanding, so that you have a better understanding on how to apply data science in the life sciences field. So you see that's the kind of opportunities you can have in the free electives. Okay, now if in Monash, Malaysia, students are required to do an industrial based learning or internship program, depending before you go into your third year of study. So the industrial work experience FIT 31999 is actually internship program. We also offer an industrial based learning program FIT 3045, which I will discuss with you later on. So this is something required by the Malaysian Qualifications Agency. So any program, any tertiary program, degree program that runs in Malaysia, those programs must include a mandatory internship program. So here in Monash, Malaysia, we actually have a unit code for that, FIT 3199, whereby students will undertake an internship program in the industry after they've completed their second year during the summer break before they go into their third year. So this is where I'll explain to you all about the course map. So in your course map, when you actually start your first year, so now you're now in your first year, semester 1. Okay, in your first year, semester 1, so you will complete FIT 1045, Algorithms and Programming Fundamentals in Python. So now, as I mentioned, data science at the end of the day is a computer science degree. I mean, the data science provides you with the additional formal training on data science field itself. So in the essence of computer science, okay, there are several main components that you need to learn. One is, of course, the programming knowledge. Second is algorithms development. Third is mathematics. And then from there we go to architectures, and from your year 2 onwards you start going deeper into the algorithms, the architecture side, the theory of computation, and then your final year you start applying your specialized knowledge into electives. So when you start your first year, the first language that you will learn is Python. So here in Monash University, the first programming language we use is Python, but primarily because Python is the world's most used language for data science, machine learning, and computer science in general. Okay, so of course you will learn other languages, Java, C, and C++ along throughout the course progression map, which I will explain later on. So in your first year, you will do FIT 1045, Algorithms and Programming Fundamentals in Python, along with MAT 1830, Discrete Mathematics, and FIT 1047, Introduction to Computer Systems, Networks and Security. Now you have an elective over here. So this elective, as I mentioned earlier on, is part of the free electives, which you can enroll in any. You can take part. You can enroll into electives not only within the School of IT, but in other schools in a university. Having said that, I would normally encourage students. To, for the first semester, to enroll into the FIT 1051, FIT 1051, which is what? Programming Fundamentals in Java. So at least in your year 1, semester 1, you will have a training in Python, and then you have a training in Java, along with a maths training, and also a general introduction to computer systems, network and security. Alright, when you go into your second semester, then one second. Okay, so when you go into a second semester, then you will take up Introduction to Computer Science, Introduction to Data Science. So this is a core unit. So whatever units you see here are all core units. And then you will do Continuous Mathematics, MAT 1841. And then you have another elective. So this elective you can now choose to take the list of electives offered in the School of IT, level 1 electives, or you can now attempt to undertake some additional electives at the School of Business or School of Science. This is based on your choice, actually. Alright. Now, when you go into your second year, this is where you will then have you'll go into your more you'll start going deeper into your specialist discipline knowledge, and also you'll start going this area. So whereby you'll still continue your foundation, but also you will go into your specialist discipline knowledge. Okay, hereby you will have the core FIT 2004 on algorithms and data structure, FIT 2094 on databases, alright, an elective unit. So you have more elective units for you to consider over here. So in this context here, we can consider you to take some electives on additional electives on Java, like FIT 2099 object oriented programming with Java, alright, and also additional electives from other schools. Okay, then in your year 2 second semester, you will do the IT professional practice, theory of computation, modeling for data analysis, and then you have another elective over here. Now, after you have completed your second year of study, then you will do an internship. So this is during the summer semester. Alright, so now we need to emphasize something here. Now, your course program, your Monash, your course structure, the Bachelor of Computer Science, the Bachelor of Computer Science, Data Science, is actually part of an indifferentiable degree in Monash, Australia. So when you enroll into the units here, you are enrolling in the same units which are being enrolled by your peers at the Australian campus. The semesters go in parallel. That's why Monash University Malaysia follows the Australian calendar, the Australian semester calendar. So when we say summer semester, which means in Australia is between the period of November until February. Alright, so your degree is Monash University. That's why it's an indifferentiable degree. Your degree is recognized by the Australian Computer Society. So the only difference is that, of course, you are undertaking the study in Monash University Malaysia. So that is the one difference that I would like to clarify over here. But as far as the learning, the content, the exams, the assessments, everything is parallel with what your peers at Monash Australia is doing. So when the same learning platform you're using, Moodle, when you enroll into FIT 1045, in your Moodle, when you see the unit page, you will see the content. Those are the same content that your peers in Australia are actually accessing also, in terms of lecture materials, assignments, tutorials, lab work, and so forth. The exams are the same exams. All the exams are prepared together between the academic staff at Monash Australia and the academic staff at Monash Malaysia. So the marking standards are similar across both campuses. So that's something very important that we want to actually emphasize to you, all of you all, about it. So we actually have an indifferentiable degree. So but having said that, the one difference is, of course, in Monash Australia, the industrial work experience is purely optional. But here in Monash Malaysia, because you're undertaking a degree in Monash Malaysia, the industrial work experience is compulsory as per the Malaysian government requirements. So you will need to do internship. So we will have an internship coordinator, Dr. Lim Mek Kwan. She will advise you when the time comes, when you enter the second year. She will advise you on how to apply for the internship. She will provide you recommendations, how to get you attached, and so forth. So do not worry about this for now. For now, the first year is for you to actually develop your core competency. In your year 1, it's very important for you to develop your core competency in computer science and also the foundation of data science. Alright. Now, finally, in your year 3, you will then take some specialized fields on data science electives. So we have a list of electives over here. So our students, they can also use the free electives to take additional data science electives. Okay. In the course map, you are only required to take 2 approved level 3 data science electives. Now, I'd like to clarify that we put parallel computing as an elective over here, but parallel computing is not formally mentioned as an approved level 3 data science elective. The approved level 3 data science electives are FIT 3003, FIT 3152, FIT 3181, FIT 3182, and FIT 3183. These are all the units which are available in Monash University Malaysia. Now, parallel computing is something that we will encourage you to take it as one of the free electives because, in my opinion, parallel computing is important for you to understand how you can build distributed systems to solve computationally complex problems. It's in a way, it's a kind of a precursor towards big data, but in big data, you tend to use high-level architectures. In parallel computing, you actually go deep into the communication between the multiple computers and how do you work on specific parallel algorithms. So let me reiterate again. Parallel computing, FIT 3143, is not part of a approved data science elective. Okay, it is an elective. The approved data science electives are 3003, 3152, 3181, 3182, and 3183. Alright. Now, An important point to make here is the faculty unit assessment hurdles. To pass a unit which includes an examination, so each unit you undertake will have a unit assessment hurdle. So the unit assessment hurdle means that it's based on your unit examination and non-examination in semester assessment. Alright, so what it says here? It says here that to pass a unit, you first need to score at least 45% or more in the unit's exam, and 45% or more in the unit's in-semester assessment, and an overall mark of 50%. So what is the meaning of this? What is the meaning of this? Now let's look at this unit. Let's say all of you will be doing 1045 this coming semester. Alright, so let's go to let me go to the, okay, let me open the browser so you can just type here. Let's say I type Monash FIT 1045. So let's go to the handbook page for FIT 1045. Okay, so this is the handbook page. So every unit has a handbook page. You can just Google up the unit code and just put Monash at the prefix there. All right. So if you look at the assessment, so it says here that this unit has a 60% in semester assessment. So this 60% in semester assessment can be based on lab work, tutorials, and some assignments that you will do during the course of the semester. Alright, so which means that the remaining 40% comes from your exam. So this is your 40%. So out of the 100%, out of the 100 percentage points that you can achieve from this unit, 60% comes from the in-semester, which means throughout the course of the semester from week 1 to week 12 assessments, and then 40% comes from your final exam, which is normally conducted between weeks 14 to week 17 of a particular semester. So in that context, how does this relate to this particular statement over here? Okay, so now let's look at this. So it says here for once you need to score 45% or more for the unit's examination. So which means that in your exam you need to score at least 45% out of these 40 percentage points. Okay, so which means that to pass the unit you will need to score at least 18 percentage points and above over 40 for the exam, for the final exam. Anything less than 18 over 40 for the final exam would mean that the student would have failed the unit. Okay, so this is very important. This is a hurdle. It's like a hurdle that each student must fulfill. Otherwise you will get a NH degree, which means N means fail, H means fail because not meeting the hurdles. So if you could do well in the in-semester assessment, but if you do poorly in the exam, okay, you do poorly in the exam, which means that out of 40 percentage points in final exam, you only score 18, you score below 18. You score below 18, for example, you score 17, which means that the student would have failed the unit with an NH grade. So the student needs to score 18 and above, 45% of these marks and above to meet the hurdle. The same thing for the in-semester assessment, 45% and more for the in-semester. So same thing here, 45% times 60. So which means that a student from the in-semester assessment, at the end of the semester, the unit coordinator will release the marks. You need to score at least 27 and above over 60 to pass the hurdle. Anything less than 27, the student would fail the unit, even though the student does very well in the exam. But the student gets less than 27 over 60 for the in-semester assessment, the student will get an NH grade. So this is something that your unit coordinator will explain to you at the beginning of the semester. We will implore you to discuss with them to get further clarification. And at the end, your overall unit must be 50 and more. So 50 is a P, 60 is C, your overall grade. 70 is D, 80 is HD, 80 and above is HD. So overall, combination of your in-semester assessment and your examination your overall score must be above 50 percentage points. So that is what the hurdles are indicating over here. Alright, okay. So if your unit is a 100% in semester assessment, then the student must obtain at least an overall unit greater than 50%. So this is something applied to your computer science project. So now, in summary, okay, so this is the life cycle that we hope that you will learn from your data science program. So we from the units we offer in the course map here, from the foundation units of data science to data analysis to data analytics, data visualization, deep learning, big data, and so forth. Okay, we hope, we aim for you all to develop the ideas. How do you understand the statistics? How do you understand the data? Okay, the ideas. So this is something you will learn in modeling for data analysis. Okay, identifying the problem, scoping, and data artifacts. Then data acquisition. How do you identify and capture huge amounts of data? Big data management. Data analytics. How do you analyze the data and generate insights? This is where you will learn in FIT 1043, FIT 3152 data analytics. Alright. And how do you visualize the insights using data visualization, FIT 3179. And finally, how do you deploy your system? This is something that you will practice in your data science project. So this is generally the life cycle of the Bachelor of Computer Science and Data Science that we aim for you to achieve. So once you have developed this understanding, so when you graduate, you have the foundation and the applied knowledge to actually pursue a career as a data scientist. Data scientist, to become a data scientist requires years of training. Alright, the undergraduate program prepares you to pursue a career in this field. Alright. Then we have a very strong lab facility. We have our own data science lab with high performance computing workstations to allow you to do computationally intensive tasks. We have a networking lab, multimedia lab, and stellar lab. Given the current online learning climate, some of the labs are now configured to be virtual labs, so students can access the labs outside of campus for specific units. We also have an advanced computing platform, a high performance computing system mostly for research students to access to perform computationally intensive tasks. Now, these are some of the data science projects. So our computer science students, they have undertaken data science related projects. Alright, just to get a hands-on experience. So they don't have the formal data science specialization, but they have undertaken the electives and then the computer science project where they undertook data science related projects to give them for them to actually have an experience or some exposure to some data science project. And these are some of the interesting work that they have produced. One is actually this is more on artificial intelligence, where they've analyzed huge amounts of data, fed it into a deep learning model and machine learning and artificial intelligence model, which is then able to automatically identify lung cancers or lung tumors. Okay, so this is very, very important in the medical field to actually help radiologists or even oncologists with better diagnosis of tumors or lung cancers. This is some kind of work the students are doing, and the kind of exposures they actually get by working with the hospitals to get data from the hospitals also. So these are kind of works that derive from research also, given that Monash is a research university. Okay, apart from that, we have students working on active surveillance, which means developing autonomous systems which is able to detect weapons in near real-time conditions. So we are moving away from passive surveillance. Now we have algorithms, complex systems that are able to scan through surveillance cameras and autonomously detect threats by looking for weapons. So our students here are able to actually develop a machine learning model, an artificial intelligence model, which is able to automatically, there's no human intervention here, automatically detect weapons, firearms in near real-time conditions. Such outcomes are very significant in terms of for a higher level machine learning understanding for aggressive human action recognition. So this kind of impactful kind of work that our students are doing, and we look forward to you actually pursuing such endeavors in the coming years ahead in your study here. So this is actually one of the outcomes of our students' work. You can see that, okay, they have developed a real-time weapon detection system. So you see, in real time, the software model is able to detect weapons from a surveillance perspective. So the outcomes of this research is very impactful because it provides a platform for aggressive human action recognition detection to allow law enforcement to combat criminal activities in real time. Okay. So apart from that, we have students working on big data projects where they use cutting edge big data platforms, Apache Kafka, Hadoop, to actually create a big data video stream and analytics platform. So you can see they have developed a visualization system. So this is part of the visualization, how they visualize and how they actually display the outcomes of the visualization system. So these are the kind of work that our students are actually done. Now some useful links for you. Okay, so we have the School of IT website. Okay, Monash University School of IT. And we have the course handbook. So let me go to the School of IT website. So let me stop this first. Okay, so so the School of IT's website contains a breadth of information. So if you go to current students, you can find information about the course map, re-enrollment unit guide, student advisory and support, unit offerings, and so forth inside here. So in the course maps, you can find the course maps for data science over here. Alright, we are for your information, okay, this is a data course map similar to what you've seen in the slides just now. We are preparing a data science with IBL course map. So industrial based learning allows you to perform a longer attachment in the industry. So this is something that we are preparing, and once we have completed it, the course management office will inform you, so you can actually opt to enroll into this program before you go into your during a year 2 of your study. Alright, on top of that, you can also find all the information. As I mentioned to you, this is an indifferentiable program. You can find all the information about your computer science and data science program in the handbook, the course handbook. So in the course handbook, your course code is C2001. Under here, if you go to the specialized part, you can find the data science specialization. So inside here then, you can find the additional core units and the electives that you can offer. Some of the electives, as I mentioned over here, so if you notice that in the slides over here, these are the electives that we have available in Monash, Malaysia. Some of the electives like advanced data analysis and computational modeling and simulation are currently only offered at Monash University, Australia. Alright, but the others, 3003, 3152, 3181, 3182 and 3183 are offered in Monash, Malaysia and also at Monash, Australia. Alright, so these are some of the useful links you can find. So in the handbook, you can find a lot of information which is extracted into the slides over here that will actually help you understand your course structure better. Then on top of that, if you need student support, please write to mumstudentsupport@monash.edu. If you're facing any hurdles, you're facing any harassments or challenges, please write to them. They're always willing to listen, to hear you out. We have a PASS program. So a PASS program is actually a peer assisted study session. So we offer this PASS program for several year 1 units and also some year 2 units to actually help students cope better with the unit. It's like a buddy tutoring system, whereby we have seniors coming in to help year 1 students to actually with some tutoring programs. So this is something that we need to discuss. Please discuss with your unit coordinators for your specific unit to see whether PASS session is being offered inside there. And you can find more information about the faculty. This is faculty's resources at the Monash, Australia site, where you can find information about academic integrity, plagiarism, and collusion. We strongly urge you all to read this. Okay, academic integrity, plagiarism, collusion is something strictly upheld at Monash University. So students need to be very careful when they are doing their assignments or the exams to avoid plagiarism and to avoid collusion. So please make sure that you actually go through this link, and then there are other information about assignments, exam feedback and performance, and so forth also. Alright, so these are the additional links. So that's about it. So thank you very much. If you have any questions, you can always contact me. I should probably include my email here, course coordinator. Okay. So please. Alright, so you can always contact me at vision.mon@monash.edu. Alright, thank you very much. we look forward to working alongside your good selves for you all to actually develop the data science competency for this program. All right, thank you.